Math 1332, Chapter 7, Consumer Mathematics, Section 1, Percents, Video 1, Converting from Percents to Fractions and Decimals. For those of you who are watching this video and are taking my class, you're going to notice that suddenly math is going to start looking like the math that you're accustomed to. There's this misconception that math is about numbers. That's like saying that literature is about the alphabet. The alphabet is just a tool that we use to create literature and study literature. Numbers are just a tool that we use to create and discuss mathematics. But in general, mathematics is not just about numbers. If anybody ever tells you that math is about numbers, correct them. Tell them, no, math is about learning to solve problems. Numbers are just one means by which we use to solve those problems. But I digress. This is going to start looking like what most people would consider a standard math class, as opposed to the set theory and symbolic logic that we've studied to this point. Now it's going to look like numbers. So let's start with what is a percent. I think most people know this, but the word percent literally means per 100. So anytime you see percent, you should think per 100 or per 100. So when you see something like 5%, it means 5 per 100. Percents are convenient for comparing relative quantities when total quantities don't match. For example, let's say I get 15 out of 20 questions correct on one test and 20 out of 25 correct on a second test. On which test did I perform better? Well, assuming the questions are weighted equally on each test, I got 75% of the questions right on the first test and 80% of the questions right on the second test. So I did better on the second test. Now, of course, in that example, I didn't explain how I converted the ratio 15 out of 20 to 75% and the ratio 20 out of 25 to 80%. And you may already know how to do that, and that's great. But I'm going to go through some conversions in these first couple of videos. So in order to work with percents, we need to be able to calculate them and use them. So let's start with converting percents to fractions. In this video, we're going to convert from percent. So we're going to start with the percent and convert it to something else. In future videos, in the next video, we'll convert from a number to a percent. Since percent means per 100, a number like 5% means 5 per 100. This is a ratio, a comparison of two numbers, but that's all a fraction is. Well, that's not all it is, but at its core, it's a comparison of two numbers. So to write 5% as a fraction, we simply need to write 5 per 100, or literally 5 over 100. So what could possibly go wrong? In general, to convert a percent to a fraction, simply remove the percent sign and write the number over 100. So what could go wrong? As a fraction, though, you're expected to simplify your answer into a reduced fraction of one whole number over another. Now, there's two important things I want to point out here. Number one, your answer is expected to be reduced. And number two, it should be one whole number over another. You'll see why that part is relevant by the end of the video. So let's take a look at some examples of converting percents to fractions. Convert each percent to a fraction, reduce your answer as necessary. Well, we already started with 5% in the previous slide. So you may be wondering, why is it here again? Well, because the answer that we had on the previous slide is not finished. 5% is a fraction. Well, 5% literally means 5 per 100, so we can just write 5 over 100. But that fraction is not reduced. The best way to think about reducing a fraction is to ask yourself, is there a whole number that will divide evenly into both the numerator and denominator? And a good strategy is to pick on the smaller of the two, because it usually, not always, but it usually has fewer choices on how to divide it. For example, the 5 on the top, there's only one whole number I can divide it by to make it smaller, and that would be itself. Now, if I can divide the bottom by 5 and still have a whole number, then I'll have reduced the fraction. I think most people know how to spot a number that reduces by 5 if the last digit is 5 or 0. On the top, 5 divided by 5 is 1. And on the bottom, 100 divided by 5 is 20. If you wanted to use a calculator to do the division, you're welcome to. I'm not testing your arithmetic skills, so feel free to use a calculator to do the arithmetic. But the final answer would be 1 over 120. Excuse me, 1 over 20. Number 2, 27%. Again, we're converting from a percent to a fraction, so we simply have to put the number over 100 and try to reduce it. Notice I said try. 27 is divisible by a few things. It's divisible by 3. It's divisible by 9. Of course, it's divisible by 27. So which of these will work? Well, it may not be obvious, so let's just try 3. That's a pretty small number. If I were to divide the top by 3, I would get 9. But if you divided 100 by 3 in a calculator, you would get 33.3 repeating. I'm assuming everybody is familiar with the bar over that 3, meaning repeating. The problem with that is it's not reduced into a ratio of whole numbers. The denominator is a fraction. So we don't want to do that. In fact, this won't reduce. This would be your final answer. How do you know it won't reduce? Just because 3 failed, does that mean something else won't work? Well, there's a way to tell if a number is reducible or not, but it requires a little bit of legwork. The way to tell if a number is reducible is to have its prime factorization, which means to break it down as far as you can as a multiplication problem. For example, 27 is 3 times 9, but that 9 is 3 times 3. So 27 is just made up of a bunch of 3s. However, if we break down 100, let's start with 4 times 25. You might be thinking, why didn't I use 10 times 10? That would work eventually. But 4 times 25 is also 100. 4 is 2 times 2. 25 is 5 times 5. Those numbers are prime numbers in the sense that I can't break them down into the product of smaller numbers. And if you'll notice, the only prime numbers here are 3, and the only prime numbers here are 2 and 5. If I'm going to reduce, I have to have some matching prime factors, which they don't. So that's as reduced as it gets. And let's try the last one. 125%. And you may be thinking, how can a percent be greater than 100? Well, there are contexts in which it's okay to have a percentage over 100. But in this case, 125% would be 125 over 100. And it should be pretty evident that I can reduce both of these by 25, or at least by 5. If the 25 isn't obvious, that's okay. Let's say you go, oh, they're both reducible by 5, because one of them ends in 5 and one of them ends in 0. 100 divided by 5 is still 20. 125 divided by 5 is 25. And hopefully at that point you would go, wait, they're still both reducible by 5. If you ever can reduce a fraction in 2 moves, it means that there was a bigger number you could have used at the beginning. 25 divided by 5 is 5. 20 divided by 5 is 4. That's not going to reduce any further. We could have gotten to this final answer in 1 move had we reduced by 25 on both sides. But when it comes to reducing, it really doesn't matter if you do it in 1 move or more than 1 move. What matters is that you get your fraction down to a point where it won't reduce any further. All right. I'm making a conscious effort to try to keep my videos under 10 minutes because I realize that some of them go ridiculously over. So we're going to end this video and continue with the part 2. It'll still be converting percents to fractions.